All right, so now that you all have discovered the formula for finding arc length, now we're going to apply it to some example problems. And so we're going to get increasingly more difficult, and we'll also go back and forth between, sometimes we might have to write our answers exactly, and sometimes we might have to write our answers approximately based off the information that's given. So in this first example, it just says find the length of arc BA. So here's arc BA. And it doesn't tell us whether to write it exactly or approximately. My preference is to do it exactly, just because it's one less step than doing it approximately. So if we think about our formula for arc length, okay, I'm going to show you both ways in this example. My formula for arc length is I take the central angle divided by 360 times circumference. And so in this case, since I have the radius, I'll use 2 pi r, but you're welcome to use pi times diameter. So I have my central angle, which is 90, over 360 times 2 times pi times the radius, which is 15. And at this point, you kind of have some options. Like some people prefer to kind of simplify what's going on. So some people may prefer to say, okay, well, 90 out of 360 is 1/4. 2 times 15 is 30. And then tack on the pi at the end. And so if I actually multiply these, I get 30 pi over 4, which if I simplify that, they're both divisible by 2. My arc length is 15 pi over 2 feet. Okay. Some people may prefer, if you go back up to the second step, they may prefer to say, okay, 90 times 2 times 15, and then divide that by 360 and then tack on the pi at the end. Just remember, if you're going to leave your answer exact, then you also need to make sure you leave your fraction in simplified form as well. Like I said, if it says to do approximate, then you would just take 15 times 3.14 divided by 2. Now, what if you're like, I don't know that I like this formula. I'm kind of more interested in the proportion because I'm really confident with solving proportions. Let's take a look at what this problem would look like using the proportion. All right, so the proportion says that I would take my central angle, which is 90, over the whole number of degrees in a circle, which is 360. And I'm going to set that equal to the arc length, which we don't know what that is because that's what we're solving for, times the circumference. The circumference is 2 times pi times the radius, which is 15. So then what you could do is you can cross multiply these two. So I have 360s equals, and for multiplying 90 times 2 times pi times 15, I'm just going to multiply the numbers because I'm going to leave my answer exact. So 90 times 2 times 15 gives me 2,700 pi. Okay. Now to get s by itself, I have to divide by 360. And so if I divide by 360, I get s equals 2,700 pi over 360. But the issue here with this final answer is this is not simplified, and so you would have to take and simplify this. So when you put this in your calculator, 2,700 divided by 360, you get 7.5. If you're leaving your answer exact, you really should convert 7.5 to a fraction, which would give you 15 pi over 2. So we still get the same answer using the proportion. My personal preference, when I need to find the arc length, I kind of prefer the first formula. And sometimes when I am having to find, like maybe work backwards to find the radius or the central angle and they actually give me the arc length, sometimes I think the proportion is a little easier. All right, let's take a look at this next one. The next one says find the length of arc BC. And so when I look at arc BC, I'm not actually given the central angle. I'm given the central angle of the other arc, which is 150 degrees. So I know, since this is a semicircle, that this little arc here, or this central angle, has to be 30 degrees. I also see that I'm given the diameter. So if I want to find the arc length, I'm going to have my central angle over 360 times, and since I have the diameter, I'm going to go ahead and just say 34 pi. So then, me personally, I like to simplify my central angle and the 360 degrees. So 30 goes into 360 12 times. So this would make the fraction 1/12 times 34 pi. So then when I multiply, I would have 34 pi over 12, which I need to simplify that. So think about what two numbers are divisible, or can I take out of 34 and 12? And the answer to that is 2. So I get 17 pi over 6, and that would be centimeters. And this would be my exact answer. All right, so let's take a look at this next one. So now we're going to get into where we're not actually finding arc length, but maybe we have to work backwards and find another piece. And so the first thing I noticed is that I was actually given the arc length here, and I noticed the arc length is expressed approximately. So that means instead of using pi in symbol form, I need to use pi as 3.14. So I was given the arc length. I can see I was also given the radius here, and it says to find the measure of arc AB. So I'm trying to find that central angle. So when I think about my formula, so my arc length formula is the central angle over 360 times the circumference. And so if I substitute in what I know that my arc length is 18.84. I don't know the central angle, so I'm going to think of it as x. And I have 2 times pi. Now I'm actually going to use 3.14 since I have an approximate arc length answer, times my radius, which is 9. So this is where some students actually find the formula we discovered a little harder to work backwards with. So I am going to show you both ways to solve for the central angle. Now for me, when I look at this, I kind of think of putting this over 1. So I'm going to multiply straight across in the numerator and straight across in the denominator. And so when I do that, when I multiply 2 times 3.14 times 9, I get 56.52x. 360 times 1 is just 360. And so then to solve, to get x by itself, I have 56.52 times x divided by 360. So I have to start by multiplying both sides by 360. And so 360 times 18.84 is 6,782.4. And that equals 56.52x. And then now this part's easy. I just need to divide by 56.52 on both sides. And when I do that, we get x is equal to 120, which means our central angle is 120 degrees. Now, if you're like, ooh, that was kind of confusing, I kind of want to see what it looks like as a proportion. Let's take a look at this next example. Let's switch to a proportion on this one. So if I do the proportion, I have to do the central angle over 360, which I don't know the central angle, so that's going to be my x. And that is equal to the arc length over the circumference. Well, I know my arc length is 18.84. And my circumference is 2 times pi, which we write as 3.14 since the arc length is approximate, times the radius, which is 9. So if I cross multiply, 2 times 3.14 times 9 gives us 56.52x. And then 360 times 18.84 is 6,782.4. I'm going to divide both sides by 56.52. And we would get x equals 120. So either method, we get the exact same answer. It just kind of depends like what makes more sense to you. And so like I said, some students go back and forth between which formulas they use. There are sometimes they prefer the proportion, and there are other times they prefer the fractional, using the fraction times the circumference. And so you can decide which formula works better for you and in which cases it works better for you as well. All right, let's do one more. So this last one, I want us to actually change, instead of finding circumference, let's just find the radius. Okay, so for this example, I can see I'm given the arc length, and one thing I notice about the arc length is that there's no pi symbol there, which means this is an approximate answer. So that means I'm going to have to use 3.14 instead of the symbol pi in my calculations. I also see that I have a central angle of 85 degrees, and I'm trying to find the radius. So I'll show it both ways again, just so you have one more example, and then you can kind of at this point decide which formula works better for you. So if I use the arc length formula that kind of focuses more on the fraction times circumference, I can see that my arc length is 12. My central angle is 85 over 360 times 2 times 3.14 times the radius, which I don't know. And then I'm going to put this all over 1 because I'm going to multiply the numerators and denominators together. And so when I do that, I get 85 times 2 times 3.14, which is 533.8 times r over 360. So then to solve, I'm going to multiply times 360 on both sides. So 360 times 12 is 4,320. That's equal to 533.8 r. Divide by 533 on both sides. And we get that r is about, and we're going to say about because we were using approximate answers. We get that r is about 8.1. Now, if you found this to be confusing, let's take a look at solving it the proportion way. So if I do the proportion way, I have the central angle over 360 degrees is equal to the arc length, which is 12, over the circumference. So 2 times 3.14 times r, because r is what we're solving for. If we cross multiply, 85 times 2 times 3.14 is that 533.8 times r. And then 360 times 12 is 4,320. And you can see we have the exact same equation that we had right there. So this one kind of took considerably less work. When we divide by 533.8, we get that r is about 8.1. So we still get the same answer no matter which method we use. So hopefully these 4 examples make you feel pretty confident that you can solve problems involving arc length.